Dear students, today we are going to discuss about organometallic compounds. What are organometallic compounds? The compounds formed between metals and organic compounds containing at least one direct metal-carbon bond are called organometallic compounds. Organometallic compounds contains at least one direct metal-carbon bond. And the branch of chemistry which deals with such compounds is called organometallic chemistry. The metal in organometallic compound is bonded to carbon of an organic molecule or radical or ion. The term metal generally stands for elements less electronegative than carbon like boron, arsenic, silicon, etc. Now we'll see the simple and mixed organometallic compounds. What are simple and mixed organometallic compounds? Simple organometallic compounds are of two types. The first one, organometallic compounds containing hydrocarbon radicals attached to the metal. Example, tetraethyl lead. Here, ethyl group is attached to lead. And the second one is hydrocarbon radicals along with hydrogen atoms attached to the metal. Example, CH3 thrice SLH. Here, methyl group as well as hydrogen is attached to the metal. So, these two are examples of simple organometallic compounds. Now, the second one is mixed organometallic compound. Mixed organometallic compounds are compounds containing at least one hydrocarbon radical along with some other groups like chlorine attached to the metal. Example is Grignard reagent, RMGX, or C4H9 twice SnCl2. Both are examples of organometallic, mixed organometallic compounds. Now the next topic is classification of ligands in organometallic compounds. The first classification is based on the number of carbon atoms through which the ligand is attached to the metal atom, or in other words we can say that classification on the basis of hapticity. Now what is hapticity? The number of carbon atoms through which an organic ligand is attached with the metal atom is known as hapticity of that ligand. The number of carbon atoms through which an organic ligand is attached with the metal atom is known as the hapticity of that ligand. It is represented by the symbol eta n, where n is the number of carbon atoms of the ligand attached with the metal. Now we'll see the classification. Ligands can be classified as monohaptoligand, dihapto, trihapto, tetrahapto, etc. The first one is monohaptoligand. The organic ligand which are attached with the metal through only one carbon atom are called monohaptoligands, and it is designated as eta 1. And here in this particular example you can see that C2H5 is attached to this magnesium through only one carbon atom, and here also C6H5 is attached to this phosphorus through only one carbon atom. So these two are examples of C2H5 and C6H5. Both are examples of monohaptoligands. Now the second one is dihaptoligand. The ligand which are attached to the metal through two carbon atoms are called dihaptoligands, and it is designated as eta 2. And in the example given here, this is Caesar salt, and in Caesar salt C2H4 act as a dihaptoligand. Here these two carbon atoms, both the carbon atoms are attached to the metal platinum present in this particular complex. So C2H4 is an example for a dihaptoligand. And the next one is trihaptoligand. These are ligands whose three carbon atoms are attached to the metal. So the ligand present here is allyl, and this complex is bisalyl nickel. An allyl group in this particular complex, it acts as trihaptoligand. Why? Because 3 carbon atoms are attached to this nickel metal. And the next example is allyl magnesium bromide. And in allyl magnesium bromide, this allyl group acts as monohaptoligand. Why? Because here this allyl group is attached to this magnesium atom only through one carbon atom. So that is an example for monohaptoligand. Now the next one is tetrahaptoligand. And tetrahaptoligand here, example is butadiene. Butadiene is attached to the central metal through 4 carbon atoms. All the 4 carbon atoms attached to this central metal. So that's an example for tetrahaptoligand, designated as eta 4. And in butadiene tricarbonyl ion, butadiene acts as tetrahaptoligand. Next one is pentahaptoligand. 5 carbon atoms are attached to iron. The pi electrons are delocalized. So here C5 cyclopentadienyl group, it acts as a pentahaptoligand. Next one is dibenzene chromium, and here also you can see that 2 benzene rings are attached to this chromium, and all the 6 carbon atoms are attached to this chromium. So that is why it's an example for hexahaptoligand. Next one is heptahaptoligand, and here 7 carbon atoms are attached to this central metal atom. So that is an example for heptahaptoligand. Cyclohepta trienal group is an example for a heptahaptoligand, and it is designated as eta 7, and this group is also known as tropylium group. Now the next one is octahaptoligand. 8 carbon atoms are attached to the metal. So that is the first classification. Now the second classification is based on the number of electrons contributed by the ligand for carbon ligand bonding. So the first one is 1 electron ligand. Here in this example, the CH3 acts as a 1 electron ligand. It contributes 1 electron for the bond formation. So we can say that this is an example for 1 electron ligand. Alkenes are 2 electron ligands. It needs 2 electrons for the formation of this particular complex. Now the next one is 3 electron ligands. Allyl group in this particular organometallic compound acts as a 3 electron ligand. It contributes 3 electrons to metal. Now the next one is 4 electron ligand. That is butadiene. Butadiene in this complex, it acts as a 4 electron ligand. 5 electron ligand is cyclopentadienyl group. 6 electron ligand example is cyclooctatriene is an example for 6 electron ligand. 6 pi electrons are there that can be donated to the metal present in the complex. So cyclooctatriene is an example for a 6 electron ligand. Tropylium ion can act as a 7 electron ligand in this complex. And the next one is 8 electron ligand, and 8 electron ligand is cyclooctatetraene. Now the next one is, here we discuss 2 types of classification for ligands, that is classification based on the number of carbon atoms to which the ligand is attached to the metal atom, and the second classification is based on the number of electrons contributed by the ligand for carbon ligand bonding.